In this video, I'll show you how to make a Newton's cradle using readily available materials. This Newton's cradle can also be reconfigured to perform a variety of physics experiments. First, you'll need some steel ball bearings. These could range in size from about 1/2 inch diameter to 1.5 inches. I found some inexpensive ball bearings on eBay that are 3/4 inch in diameter. We need to turn the ball bearings into pendulum, and I'll show you a method to do this by gluing pieces of wire onto them. Take some solid core insulated wire. I'm using 22 gauge wire, but any gauge from 20 through 26 should work well too. Cut the wire into 1-inch pieces, one piece for each ball bearing. Strip off about 1/4 inch of insulation from each end of the wire. The plan here is to glue the insulated part of the wire to the ball bearing, and the wire will later be removed, leaving a small tube that we can use to thread the pendulum. Get a Sapphire nail file. You should be able to find this in a drugstore, grocery store, department store, and use it to scuff up the top of each ball bearing. You want to keep the same side of the ball bearing facing upwards, so I'm letting the ball bearings rest on top of 1/4-20 nuts, but you could also rest the ball bearings on bits of modeling clay. The next thing you want to do is to epoxy pieces of wire to the top of the ball bearings, but if you're like me, you discovered your old tube of epoxy has welded itself shut. Well, things like this happen all the time in experimental physics, so you roll with it and get some new epoxy. Incidentally, make sure you use slow-drying epoxy. So mix this up, and then use a toothpick to spread a drop of the epoxy all around the central piece of each wire. Try not to get any epoxy on the bare metal. The epoxy should only touch the plastic insulation surrounding the wire. Now place the epoxied wire on top of the ball bearing so the drop of epoxy rests on the scuffed up part of the ball bearing. Let this dry for 24 hours. Once the epoxy is dried, use some pliers to gently pull out the wire, leaving the plastic insulation embedded in the epoxy. It helps to twist the ball bearing around the wire, almost as if you're unscrewing a nut off a bolt. Be patient, this can take about a minute or so, but eventually the wire comes out. Now, take a sharp knife, like an X-Acto knife, and cut off the ends of the plastic insulating tubes so they are now flush with the drop of dried epoxy. Now all you need to make the pendulum is a short length of fishing line. Thread the fishing line through the plastic tube in the epoxy, and you'll have a Newton's cradle pendulum, and it should swing fairly easily. All you need now to finish the Newton's cradle is to make a frame to support the pendulum. You can do this any way you want, but I'll show you a method using some dowels that lets you reconfigure the Newton's cradle using pendulum with other sizes and masses. First, get 4 small wooden blocks and some 3/8 inch dowels. An easy way to make wooden blocks is to take a 1-inch square dowel and cut it up into cubes. Also cut the 3/8 inch dowel into smaller pieces. In this video I cut 6 pieces 5 inches long and 2 pieces 3 inches long, which conveniently adds up to 3 feet, which is the size of one dowel. 4 of the 5-inch pieces will be legs, the rest will form the main frame. Also use a drill press to cut some 3/8 inch holes halfway through the wood cubes at right angles to each other. Fit the dowels into the holes in the cubes to make a frame for the Newton's cradle. We'll attach the pendulum to the frame using some tie-back pins, which are more commonly used for making curtains. I got these tie-back pins from Joann's Fabrics. You can also make your own hooks out of paper clips. Put 5 pins around each of the main dowels. Thread the fishing line through a pendulum bob and tie one end to a tie-back pin. I like to make the connector more secure by hot gluing the end in place. Do the same for the other side of the pendulum. Attach the next pendulum bob as you did the first, but make sure the second ball is exactly the same height above the table as the first ball. You don't need to worry if they don't completely line up with each other. You can adjust the position later on, but they do need to be at the same height. Once it's all set, you can hot glue the fishing line in place. Once all the pendulum are attached, use a triangular file to notch the frame to prevent the tie-back pins from slipping. The notch spacing is the same as the pendulum bob diameter, which is 3/4 of an inch for these balls. Make the notches deep enough to keep the tie-back pins from sliding. If you want to make the Newton's cradle permanent, you could hot glue the tie-back pins in place. You can also hot glue the balls in place, but first make sure that they all even and line up with each other. Now you're ready to try some experiments. What happens if you replace steel balls with rubber super balls? What happens if you replace only one of the steel balls with a super ball? What happens if you use balls with different masses? Can you arrange the ball so the last ball swings higher than the starting height of the first ball? Thanks for watching.